Okay, another problem with CL DEPA. After a hard day at the DEQ, Mr. Richardson, Mr. Richardson was a beloved teacher up here. He went off to the Department of Environmental Quality, friend of mine here. So he's in a lot of these problems, him and Patches. Patches is a cat, crazy cat here. So Mr. Richardson steps in a pile of Patches' poo in his front yard. He spots the fat cat asleep on the icy roof of his house. He climbs the ladder, sneaks up behind the slumbering fat cat. Well, so far, no physics, just the setup. He gives Patches a big shove, pushing the cat towards the roof's edge. Now, Patches is going to slide off the edge at, now we got a, oh, it's not good, sorry. Now we have a, the physics part. Patches slides off the edge at 5.4 meters per second. So that's going to be, now it's a velocity, but I don't know, I can put a V there, but I don't know whether it's a V naught or a V final, or it's probably not a V bar, but until I finish reading the problem. After accelerating down, after makes me think that's V final. After accelerating down to 3 meters, that's obviously delta X, roof, picking up speed, so it's sort of like a ball rolling down a ramp. Will have that constant acceleration. Is this icy or something? So a lot of times in physics problems we make them icy to eliminate or to negate friction until we get to the friction part. Picking up a speed at a rate of 2.4, and there are the units on acceleration always give it away. 2.4. Hey, isn't that the same acceleration Joe had? Almost. Joe in the previous problem was 2.2. Here we are 2.4, so he does a pretty good shove. With what speed did Patches leave Mr. Richardson's hand? So if we're looking for V naught is the question. Okay, so we're not, and here's part of kinematics. I've had students that say, wait a minute though, wasn't Patches, if Mr. Richardson gives Patches a shove, well, isn't V naught 0? We don't pick up the action there. Galileo didn't pick up the action there. It's Newton. We're going to have to get to Newton's laws before we can start to look at forces. So what we're saying is he shoves Patches, now Patches has left his hand. Now once Patches leaves Mr. Richardson's hand, the only force acting on Patches is, assuming there's negligible friction, I'm waiting for you to think about it. Okay, you're right, gravity. Now, what did Galileo say? It's diluted gravity, but it's still gravity. Patches is not in free fall, but what's causing Patches to slide down the roof is gravity. No, Patches sleeps through. I mean, Patches has 9 lives, and Patches, and these problems, people get upset. Well, you're killing Patches. No, I'm not. Patches always survives, all right? So I made a little note there, just in case. Okay. So here we go, pretty well laid out, but one thing that's really missing here is time. Now when I don't have time, I can't use first orange. I can't use second orange. I have to use third orange. So third orange, where we got the C and the L, the drawing's good here. We have an angle. And later on, I agree, when we get to forces, the angle will matter. But right now, it's giving us all that we need. So I know that delta X, this is my roof, and delta X down that roof is 3 meters. And V naught is going to be, I'm trying to find that's my question mark. V final coming off the roof is 5.4 meters per second, and my acceleration down the roof is 2.4 meters per second squared. So not only did I circle and I labeled, I also did a drawing, and there did it again, because you really want to make sure that you know kind of where you're at. So now we go with E on CL DEPA, our equation, and don't put in symbols. The mature student You show your physics prowess by being patient and holding off. It is the rookie that wants to throw numbers at a problem immediately, because that's maybe the way you did it in 7th grade. You're now a senior or a junior or maybe a sophomore, but don't throw numbers until you've isolated the symbol. That skill right there will make what comes later much easier. So, I said use the third orange, didn't I? And then, for some reason, I used the second orange and went all through all this work to isolate the V naught, and then I went back and looked at my numbers and said, whoa, so, so anyway, back to what I was saying, very important to use the right equation. So V final squared equals V naught squared plus 2a delta x. Alright, so I want to end up with V naught, or V naught. So I'm going to isolate that. Well, I'll bring the 2a delta x over here, and I'm going to then if a equals b, b equals a, so you can switch that. I'm going to do that too. I like to have what I'm looking for on the left. I don't know why that is, those quirks. So go through and I say, alright, so V naught squared equals V final squared minus 2a delta x. Okay, so I brought this over here and then switch the two. Well then, to find that, find V naught, I'm simply going to take the square root of the whole thing, V final squared minus 2a delta x. We do this a lot, this equation. Alright, so there it looks good, and now all I got to worry about is plugging and chugging. And so, go ahead and do that. I end up with V naught then is the square root. V final, okay, 5.4, and do put the units in there. It's required, and it's just a good idea, safety valve, minus 2 times 2.4 meters per second squared times 3 meters. Okay? And at that point, remember you're at 9 out of 10 or 19 out of 20 points right now. So if you want to, you can move on. Good idea though on homework, go ahead and punch it in to make sure you're getting the answer at the bottom, see if there wasn't some colossal screw up on your part or my part. But when we punch that in, we should get, and I'm looking, that's the way I did it there, yeah. So we should get 3.84 meters per second. And now remember, the last step is to see if that makes sense. Remember, that's the velocity that Patches has. Patches was at zero velocity, but then in the push, as he pushed Patches, Patches accelerated or went through a jerk or whatever it was. Instead of pushed him, shoved him, so maybe it was a snap, like wah! So pushed him very hard or whatever. But the instant Patches left his hands was moving at 3.84 meters per second, and that's when gravity took over, diluted gravity, and friction is negligible because of the snow. So diluted gravity and air drag, very minimal here at this low speeds. That's when gravity took over. Alright? And so that's my initial velocity once it leaves the hand. If it's like shooting a gun, boom, and we're seeing how far does the bullet go, the muzzle velocity, which is the velocity the bullet has as it leaves the muzzle. And we've done problems where we're looking inside the barrel. Well, in that case, the initial velocity is 0. It's the velocity of the bullet before the gunpowder explodes, and then it expands it through the barrel. And maybe my final velocity is the velocity it leaves the barrel with. But most times in guns, you're shooting a gun or a cannon or a tank or something, the initial velocity is called muzzle velocity, and that's the velocity the bullet leaves the barrel at to go off on its projectile motion, or whatever, and it would be projectile motion. Okay? Well, good. I'll see you on the next page.